Our next speaker is Ivan Krul, who will talk about their SoK paper about trusting self-sovereign identity. Ivan.
Thanks. Yeah, so I'm here to present our SoK on trusting self-sovereign identity from myself and my collaborators, Helen Pikes, Ishmael Ruse, and School Frontier. It's really hard to fit an SoK into an 11-minute presentation, so I'm going to take 12. So if we think about digital,
tell us that.
well, I'm warning you so I don't get cornered, right? So if you think about digital identity, honestly, like motivating is kind of a waste of time. I think we're all familiar with it. In Australia, we've set aside $250 million to deploy digital identity. We already have it in our states. In 2023, Louisiana was one of many states that are now requiring that you authenticate with your digital ID to make sure you're over 18 before you can go to adult content websites. If you flew here on United, you probably were prompted to take a picture of your passport in the app and send it to a third party to verify before you get to the airport, and they'll pinky promise to keep it safe for you, so don't worry. So the obvious question is, are there any problems with this current status quo, right? We're rapidly digitizing, and is there any challenges? And the cartoon I use is a newspaper article from a major telecom in Australia when they had to apologize for losing about half of Australia's driver's licenses in a data breach. So we have some significant problems, right? We had Optus, they lost a lot of information just last week. The ID verification service used by TikTok, Uber, Twitter, they lost all of their data. I think about once a week I find a new article to cite in my thesis, right? It's a genuine problem, and I mean, I'm obviously not the first to identify this, and since about 2017, self-sovereign identity has been discussed as a potential solution to this problem. And it's a very traditional credential exchange. So you have three entities, you have your issuer, and they're going to issue credentials to an identity owner, and then the identity owner sends those credentials to service providers. And there is kind of an assumed and implicit trust between service providers and issuers. We're kind of making the assumption that there is an existing authority who can issue credentials, right? We already accept governments issue driver's licenses, and we're not really challenging that. The key differentiator is we want to make sure that these credentials are stored in wallets owned by the identity owners, so they have the sovereign control over their self-sovereign identity, and the credentials are just typical attribute-based credentials. So in the example of a driver's license, there's someone's name, their birth date, their address, their license number, who issued it, and some form of digital signature as proof. So my slide was called SSI is a solution, but what is it a solution to? And if you're going to be really pedantic, what is the point of digital identity? And for my convenience, I'm going to use a really simple definition is we use identity and we present it to build trust between untrusting parties. So a service provider doesn't know who we are, so we show them our card going in, right? Like, if the bartender asks, are you 18, everyone's going to say yes, right? They don't trust us. And we've seen a lot of history and a lot of examples that, as identity owners, we should stop trusting service providers. They don't deserve our trust. So we have two untrusting parties, and we need to build trust between them. And all right, now we're getting to the SoK part. In SSI's academic literature, in industry implementations, and existing surveys, there really is no existing definition on what trust means. Either we're making different assumptions on where trust exists and where we need to build it up, and it's a whole mess. And as a consequence, across surveys, we're missing properties and features in them. Implementations are doing things that don't quite make sense. Industry is implementing things that are just off the rails sometimes. And we don't really have a framework, and we have a pretty limited means to be evaluating these new features. And because this is an SoK, I'm also going to complain about the lack of standardized terminology. So, for our contributions, we provide a comprehensive analysis of trust in SSI. We analyze known implementations of SSI, both academic literature, but we also looked really heavily at this industry implementations to see what they're doing. And as an outcome, I hope that we provide a foundational framework for future SSI research and development. And I'll very briefly go over some of the key points. So rather than just talking about this credential exchange, these three parties, we're actually going to talk about a trust over IP stack. We're going to provide a lot more detail. This is sort of modeled over the TCP IP stack. And it's not original from this work, it's from the Decentralized Identity Foundation. So on the bottom layer is the trust support, and it's these public utilities to anchor trust. So I said, we making an assumption issuers exist and they're trusted. How do we anchor them into an SSI system? And that's the responsibility of the layer one. We do this through decentralized identifiers or DIDs, and they're URIs that will be dereferenced to some sort of document with their public key and their endpoints and information like that. Traditionally, 2017 era, this was very blockchain. The DIDs resolved to a blockchain. That's not really the case anymore. Layer 2 is not that interesting. We're just using that to communicate, and I'll skip it for time. And layer 3 is trust tasks with a credential exchange, and for everyone in this room who's done attribute-based credentials or anonymous credentials, this should look familiar because it is the same thing. SSI is not proposing something different. We're taking attribute-based credentials in those works, and we're inserting it into this framework. So, credential exchange. And then with the credential exchange, we have these availability for extensions or additional properties. And the two that everyone likes to talk about is selective disclosure and unlinkability. So in selective disclosure, if I'm presenting my credential to a bar to show I'm over 18, they don't need to know my address, right? So with selective disclosure, you only provide the credential, like the claims you need, so you only give your birth date. And then with unlinkability, I shouldn't be tracked across my presentations, right? It's just additional usage information we don't need, so you present in an anonymous way. I'll say that carefully. And then the top layer here is the trust applications. So these are the applications in the governance structures that are actually deploying some sort of SSI ecosystem. So, your EIDAS2 in the EU is coming out pretty quick, and you should watch out for that. And, in Australia, we're rolling out digital ID. Like, the government is really the entity that's going to be pushing SSI, and they're going to be defining the trust applications. And these applications, they're naturally making threat assumptions. They have some assumed level of trust, and they're naturally going to accept some threats exist. And when you have a threat, it kind of implies there's a risk, right? And then from the risk and from the threat, you need to provide a mitigation. Like, how do we fix this problem? So I'll just give an example rather than talking about it. In the case of selective disclosure, the threat is service providers overcollect identity information. The risk is we have our identity breached, like we always do. The constraint is that identity owners should be able to minimize the data they share, and the mitigation is selective disclosure, which we extensively surveyed in our paper. So we did this for 11 categories and 16 threats, including identity owner identification, non-transferability, key and wallet management, selective disclosure, unlinkability, a whole lot more. For each of these, there's varying mitigations. There's a whole set of them. If you want to know them, they're in the paper. And then we were kind of left with like this disparate collection of threats and mitigations just thrown everywhere. Right? We have selective disclosure to protect us. Why and when do you use it? So we created 3 broad categories, and these are, I'll highlight, recommendations and not rules on what level of trust applications have. So there's trustful, intermediate, and zero trust. So in a trustful application, there's not really sensitive credential data, and we fully trust all the entities, the identity owners, the service providers, the issuers. Yeah. In intermediate, we have quite a bit more sensitive identity data. Think now we're doing like government-issued IDs. We don't really trust identity owners as often, so we want some protections against them, right? They're posing some threats. We do not trust service providers as much anymore, please, right? So we have selective disclosure and protect against there. And we still maintain really a lot of trust in issuers. We still assume there is some trusted issuer or set of issuers. Zero trust is a really small edge case that kind of falls into SSI sometimes, where maybe things are really sensitive. We still kind of trust identity owners, but we just don't trust we don't want any issuers. We don't want to trust any sort of centralized authority. And then we provide recommendations from all of our threats and where they would fit into these categorizations. So in the case of selective disclosure and unlinkability, in a trustful model where we trust service providers, we don't need these. So we don't recommend including them. But if your application is subscribing to an intermediate trust or a zero trust model, I would really recommend looking at building one of those. We also, and I'm not going to talk about all of the tables in the slides, we surveyed all of the different approaches to each of these layers. So we have a bit of a catalog of components on the layers and the different approaches to these extensions and mitigations. And then we surveyed a whole lot of academic contributions. We categorized them based on those 3 trust models, and then we looked at like what did they actually implement and compared the 2, and I'll talk about that. And we looked at industry's credential profiles, they like to call it, because they don't want to use the term SSI anymore. Again, what's their trust assumption? What do they actually implement? And we compared the 2. What is academic versus industry doing? And I'll just quickly conclude with a few key takeaways. So first, I want to say this very clearly. SSI is not a blockchain identity system, okay? Industry implementations tend to prefer, and by tend I mean every single one of them, are using traditional public key infrastructure, okay? DID web, they're not using blockchain anymore, so throw that away. For better or for worse, industry implementations are using very generous trust models. Most of them we looked at are trustful implementations with no concerns about the threats posed by these service providers. These are the industry implementations they want to use for like the European digital identity and in Australia, so kind of a concern. And there's a really significant and major divide between academic research and industry's implementations on actually where there is trust in SSI. And this is portrayed in my paper, but talking with people who work on these credential standards in industry, it's just a common knowledge that the work SSI academics are doing is just not being recognized in industry because we are so unaligned. Also, across industry and academia, I'll attack both very quickly. Very few works actually address the threats they claim they consider. Yeah. So, for future work, please let's be clear on what is our trust assumption, what are the threats actually implied by that, what mitigation should we be doing to protect this, what components are we actually using, what are we implementing, are we using BBS, CL, where, why, right? And I won't talk about it because I have no time, but it's not lost on me, there's anonymous credential people in this room. Unlinkability is really ambiguous in SSI. The anonymity of anonymous credentials isn't really mapping well to what people think unlinkability is in SSI. If you want to know about it, talk to me or read my paper, but it is an ongoing concern. Thank you. 45 seconds over.
Hi, I wanted to understand whether you found a connection between unlinkability and duplicate identities, because you mentioned that multiple presentations should be unlinkable to each other, and I think that is directly in contrast with the requirement that you should not, a single person should not have multiple identities.
That's a really difficult question to answer. So like unlinkability is looking at, I'm just presenting my identity to the service provider after I've been issued it. And unlinkability in that case is arguing that service provider shouldn't be able to see, it's the same credential, right? It should be basically a zero knowledge proof. That does not mean that the issuer shouldn't be checking that I'm not collecting duplicate identities. That's a separate discussion, and that's actually a thread in the paper if you read it. Yeah, I could go on too long for that.
Okay, thank you.
I just have a quick question on self-sovereign identity and the W3C DID standards. And I say this as an ex-W3C employee who was very suspicious of that standard. So if no one's using blockchain more, which is probably a good thing, and they're just like servers talking to servers, and the DIDs are just like, hey, it's a redirect to a server, how is self-sovereign identity like in any way decentralized or in any way different than just like handing someone the key with like an OAuth protocol? It seems to be, that's well understood and studied. And like what's different, and why can't we spend a lot of time building anonymous credential tech? Why aren't they using any of that tech? Why are they reinventing the wheel with like worse cryptography and worse security trust properties? It's kind of confusing. They just seem to be using self-sovereign as like some sort of fairy dust to make the stuff more attractive.
Yes, thank you. Okay, why are they? Just to confirm your response, yeah, pretty much blockchain's gone, right? Everyone's using DID web, which is literally just going to a URL and looking it up.
That's a server talking to a server, right?
Yeah, or like a phone talking to a server client, right? Whatever. And then we're just trusting traditional PKI. Why do we keep talking about blockchain and other stuff?
Why do we call it self-sovereign? What's different than like the 80s, let's say Stuart Brand's early?
Yeah, nothing. Nothing's really different. But now we are seriously in a position where many regulators and governments are trying to use this, and the industry is actually really on top of it, but academia is not. And we keep talking about self-sovereignty and blockchain and this and that, and we're just arguing into an echo chamber rather than actually being useful. On your topic of OAuth, there is wonderful work by the OpenID Foundation on this. It's OpenID for verifiable credential issuance, presentation, and something else. Kind of combining OAuth protocols with the issuance and verification of SSI credentials, and that's gaining a lot of traction.
Maybe we'll take one more quick question. If you can make it quick.
You guys got it. It's the theme of the session. It's a dual question, so it makes it even harder. So first, do you have any insight what's going on behind the scenes that the providers are creating trustful environments and trusting service providers even with the risks that might pose? The second one is, in your SoC, you largely looked at the kind of low-hanging fruits in terms of selective disclosure and unlinkability, which has been around since 2001 or something. What about the things we really could do with anonymous credentials like predicates? You mentioned them, but
Yeah.
where is that going?
Okay. So I really hate to say this, it's fine. Okay. So in terms of in terms of industry's implementations of being really trustful and not caring about any of this, what I've read, because I skimmed the Australian government policy, is they're just going to accredit service providers. So then we're just going to have like a trusted set of service providers, and you need to, as a company, apply to be able to collect identities rather than having like a free and open identity system. I'm not a fan, but it kind of does negate a lot of those issues. And your second question?
The second one is, what about the higher end functionality in terms of predicates?
Yeah, so in my SoK, predicates is a type of selective disclosure.
Ah.
So, yeah.
Thank you.
Thank you.
Let's thank the speaker again.